There are 7 things happening inside the body once a person turns 50. Each one is silent. Each one is already underway right now for anyone old enough to be in that range. Most people only notice 3 of them, because the other 4 are happening inside organs nobody ever thinks about. By the 6th one, an entire organ has shut down so completely that by 60, it is essentially gone, and most people never even knew it existed in the first place. Most of what gets said about turning 50 is wrong, or at least incomplete. A birthday card, a joke about reading glasses, and that is usually where the conversation stops. The actual list of what is happening mechanism by mechanism is far stranger, far more interesting, and in several places considerably more solvable than most people would guess. The first one is the one people feel earliest. Around 50, almost everyone, including people who had perfect vision their entire lives, starts holding the phone a little further away. The restaurant menu becomes harder to read in dim light. Small print on a pill bottle stops being readable without effort. This is presbyopia, and the mechanism behind it is genuinely strange. The lens inside the eye, the structure responsible for focusing light onto the retina, is made of layered clear protein, somewhat like an onion. In a young eye, that lens stays soft and flexible. A small muscle behind the eye, called the ciliary muscle, contracts to make the lens bulge for close focus and relaxes to flatten it for distance, squeezing and releasing thousands of times a day without anyone noticing. As the years pass, new protein keeps getting added to the lens in layers, while the older layers in the middle never disappear. They simply compress, and as they compress, they slowly cross-link with each other, the same way an old rubber band stiffens after years sitting on a windowsill. By 50, the lens has become so densely packed that it can no longer change shape on demand. The muscle behind it is still squeezing. Researchers have actually measured the ciliary muscle gaining roughly 50% in contraction force during this transition, straining harder than ever to move something that simply will not move anymore. The eye is not weakening. It is a fitness instructor yelling at a rock. This is why presbyopia becomes essentially universal by 50, and why a related but distinct issue tends to show up around the same time cataracts. As those same proteins continue cross-linking, they begin scattering light in addition to becoming inflexible, gradually clouding the lens. Most people do not notice early cataract formation at 50, but by 60, roughly half of people have some degree of it, and by 80, nearly everyone does. Cataract surgery, removing the clouded lens and replacing it with a clear artificial one, has quietly become one of the most common surgeries performed anywhere in the world. The second major shift involves the skin, and the actual mechanism is considerably stranger than simple dryness. Collagen, the protein providing structural scaffolding underneath the skin, starts declining at roughly 1% per year after the age of 20. That does not sound dramatic on its own, but by 50, the cumulative loss sits around 30% below peak. For women, there is an additional hit layered on top within 5 years of menopause. An extra 30% of remaining collagen disappears, largely because estrogen had been protecting that collagen all along, and once estrogen drops, the collagen drops with it. At the same time, sebum production, the natural oil keeping skin moisturized, falls by roughly half between 20 and 50, which is why skin that once managed its own hydration suddenly starts feeling tight and dry. Layered on top of both of these, the rate at which skin cells turn over slows refreshing every 28 days in someone's 20s, stretching to 40 days or more by 50. Old cells linger longer, and the complexion looks duller, not because anything has gone wrong, but because new cells simply take longer to arrive. Elastin, the separate protein responsible for skin snapping back into place after being stretched, behaves differently. Still, production essentially stops in adulthood, meaning once it degrades, it does not get replaced the way collagen does. Hair follows its own quiet timeline through all of this. By 50, roughly half of hair follicles, on average, have permanently switched off pigment production, which is why gray hair tends to feel less like a gradual shift and more like the accumulated result of millions of small, individual failures happening at slightly different times. The third major shift involves bone, and the timeline here genuinely surprises most people. Bone density peaks around 30, and from that point forward, the body is essentially spending savings rather than building new reserves. Bone itself is not static. Cells called osteoclasts continuously dissolve old bone, while cells called osteoblasts continuously build new bone. And in a young body, the building outpaces the dissolving. After 30, that balance shifts gradually in the other direction. And by 50, bone density is declining at roughly 0.5% to 1% per year, compounding silently with no symptoms until something eventually breaks. For women specifically, the picture changes dramatically after menopause. The rate of bone loss jumps to around 2% per year and stays there for 5 to 10 years, with some women losing as much as 20% of total bone density in that single decade. The mechanism traces back to estrogen, which had been suppressing the osteoclasts responsible for dissolving bone. Once estrogen disappears, those cells go essentially unsupervised, working faster than the osteoblasts can keep pace with, leaving microscopic gaps throughout the bone's internal lattice structure, especially in the spine and hip. The encouraging part is that bone, much like muscle, responds directly to load resistance training, and weight-bearing movement send a clear signal to keep building. And research has shown that even modest amounts of resistance training in people over 50 can measurably increase bone density in exactly the areas that matter most. The fourth shift involves muscle, and the 50s are specifically where this stops being a slow trickle and becomes a real, measurable loss. After 30, muscle mass declines roughly 3 to 5% per decade. After 50, that rate roughly doubles, meaning the loss can shift to 1 to 2% per year rather than per decade. The specific fibers that disappear first are the fast-twitch fibers, the ones responsible for explosive power, the kind that let someone sprint after a bus or catch themselves when they trip. Slow-twitch fibers, used for everyday walking and endurance, tend to hold on considerably longer, which is part of why people in their 50s often notice they can still walk plenty of distance, but their reflexes have slowed and standing up from a low chair suddenly requires more conscious effort than it used to. Hormones drive much of this. Testosterone in men has been declining roughly 1% per year since 30, reaching about 20% below peak by 50, while growth hormone sits around 30% below where it was at 20. Both hormones function as signals, telling muscle tissue to stay built and maintained, and as those signals quiet down, the muscle responds accordingly. The reliable fix here is genuinely one of the most well-established interventions in all of medicine, resistance training heavy enough to limit repetitions to roughly 6 to 12%, performed 2 or 3 times weekly, paired with adequate protein spread across the day. Multiple studies, including ones involving people well into their 70s and 80s, have shown measurable muscle gains within 8 to 12 weeks of consistent resistance training, even among people who had never lifted weights before in their lives. The fifth shift is harder to notice directly because it happens entirely during sleep. By 50, the average person has lost roughly half of the deep sleep they experienced at 20. Sleep is not a single uniform state. It cycles through distinct stages, and the deepest stage, called slow-wave sleep, is where the brain generates large, slow electrical oscillations visible on an EEG. During this stage, growth hormone gets released, tissue repair occurs, long-term memories get consolidated, and based on research only emerging over roughly the past 15 years, the brain literally washes itself. A system called the glymphatic system uses cerebrospinal fluid to flush metabolic waste out of brain tissue, and during deep sleep specifically, the space between brain cells expands by roughly 60%, allowing that fluid to flood through and carry away accumulated debris, including a sticky protein called amyloid beta, the same protein implicated in Alzheimer's disease. By 50, that cleaning process is operating at roughly half its original capacity. By 60, the loss reaches around 70%, by 70, around 95%. This decline is not gradual so much as it accelerates sharply, and researchers tracking people over periods as long as 17 years have found that the rate of deep sleep loss in someone's 50s and 60s is one of the strongest predictors of later dementia risk, suggesting deep sleep loss may function as an upstream cause rather than merely a symptom of aging. The sixth shift involves an organ most people have genuinely never heard of: the thymus. Sitting behind the breastbone, roughly the size of a walnut, the thymus is where immune cells called T cells go to complete their training before being released to patrol the body for the rest of a person's life. The thymus peaks in size and activity around puberty, then begins a long, slow shrinking process. By 30, it is already noticeably smaller. By 50, it has largely become fatty tissue, with only scattered patches of functioning thymic tissue remaining. The consequences extend well beyond the organ itself. The T cells protecting the body were mostly generated before 30, and as those existing cells age and wear out, the body has fewer fresh replacements arriving to take their place. This is a meaningful part of why older adults respond less robustly to vaccines and tend to struggle more against unfamiliar infections, not because the entire immune system has weakened uniformly, but because it is increasingly running on an aging force with no significant new recruits joining. The seventh and final shift happens at the cellular level, and in many ways it helps explain why the previous six are all connected rather than isolated. Every cell carries a built-in division limit, governed by structures at the ends of chromosomes called telomeres, which shorten slightly every time a cell divides. Once telomeres become too short, a cell stops dividing and enters a state called senescence, not dead, simply stalled, while still occupying space and consuming resources. The strange part is that these senescent cells begin secreting a steady stream of inflammatory signals, a process researchers call the senescence-associated secretory phenotype. In youth, very few cells reach this state, and the immune system efficiently clears the ones that do. By 50, more cells are reaching their division limit. The immune system has become less efficient at clearing them, and the ones that remain keep pumping low-grade inflammation into surrounding tissue, a phenomenon increasingly referred to as inflammaging. These so-called zombie cells are not contributing anything productive, yet they remain active enough to quietly worsen nearly every other process already discussed. The bone loss, the muscle loss, even some of the skin changes all carry a senescent cell component layered underneath them. What makes all 7 of these changes worth understanding together, rather than separately, is that they are genuinely interconnected. Inflammation from senescent cells contributes directly to bone and muscle loss. Lost deep sleep means the brain clears waste less effectively, which feeds into longer-term cognitive decline. A shrinking thymus means the immune system becomes less capable of clearing senescent cells in the first place, which increases inflammation further, which worsens nearly everything else on the list. It functions as one interconnected system, rather than 7 separate problems happening to coincide. The decade after 50 is not the quiet, gradual drift most people assume it to be. It is closer to a significant reorganization, different hormone levels, a different immune environment, different collagen turnover, different bone density, different sleep architecture. Most people walk into their 50s without ever being told any of this in advance, left wondering why a body that worked one particular way for decades suddenly seems to be operating under different rules entirely. The interventions that meaningfully help are not exotic. Resistance training at least twice, ideally 3 times, weekly. Adequate protein spread evenly across each day. A cool, dark, consistent sleep environment. Actually requesting blood work covering hormone levels, bone density, and inflammation markers, since routine checkups frequently skip all 3. Morning sunlight, whole foods, walking after meals, lifting heavy things regularly, and going to bed at a consistent time. None of it sounds dramatic, because it genuinely is not. It is the unglamorous, repeated, boring stuff that compounds meaningfully over years. Research on aging consistently points toward one conclusion worth sitting, with the single strongest predictor of how someone in their 50s ends up doing decades later is not genetics or childhood circumstance. It is the specific behavior chosen during the decade currently underway. If this changed how you think about what your body is actually doing right now, share it with someone who needs to hear it. Subscribe to Your Body Decoded for more videos exploring the real biology behind what happens inside your body as the decades pass.